first couple of problems I'm going to show you are translations, which is a slide. We're going to plot our original points. So A is at 1, 2. B is at 4, negative 2. And C is at 7, 5. Alright, so I'm going to take this triangle, and this is the translation, and this is also sometimes shown in a vector, which would be negative 3, positive 2. Just put in the V's. And either way, that is just telling you how much to slide your shape. You're going to go left 3, up 2. The first number tells you to go left or right. The second number tells you to go up or down. Negative would be left. The second number being negative would mean go down. So I want to take this whole shape and go left 3, up 2. I'm going to take each point. It doesn't matter which point you start with. Go 1, 2, 3, 1, 2. And this would be A prime. You put the little prime mark, lets me know that that's your second shape. C prime and B prime. If it crosses itself, that's fine. That'll happen sometimes. Alright, that is the easier way to do it. You could, I'll show you the algebraic way of doing it. You can take negative 3 and positive 2 and apply that to each one of the coordinates. So you could have said 1 minus 3 and 2 plus 2 gives me 0. This is where my A prime should land. You could take 4 minus 3 gives me 1, negative 2 plus 2, 0. No. Yeah. So that should have been 4. Would be my B prime. C, 7 minus 3 is 4. 5 plus 2 is 7. Would be C prime. So my A prime landed at negative 2, 4. B was at 1, 0. C was at 4, 7. So if you liked that way better, you can add your vector or your translation to each coordinate, get these, and then plot these points. I would rather just count over, up, and be done. Okay, another example, 1, 4. I'm going to plot my original shape is A. I do want you to label each point as you go. B is 3, 3. C is 1, 8. All right, this whole shape needs to go left 6, down 3. Take each point, doesn't matter which one you start with. Started with C, so that would be my C prime. And if I know, and all of these are not going to be changing the size of your shape, you're just moving the shape around. So if it's too wide here, it's going to be too wide here. It would be D prime. This goes straight down 1, 2, 3, 4, 5. So I can come here and go straight down 1, 2, 3, 4, 5. If you do not understand that shortcut, don't worry about it. Just doing the left 6, down 3 every time. So if we don't understand the shortcut, we'll just take A and go left 6, down 3. It would be A prime. So my shape should never change size here. It is only going to move on the graph. Alright, for a reflection, we will usually be reflecting over an axis, either the y-axis or the x-axis, not always. So we're going to reflect over the x-axis, and we have point P, which is at 1, 1, and Q, which is at 4, 5. So usually we have a shape, this is just a line segment, and we're going to reflect that over the x-axis. When you reflect over the x-axis, each point needs to stay the same distance away. So if my P, if I went up 1 from my line that I'm reflecting over, then I need to go down 1 for P prime. Q, if I go up 5, then I need to go down 5. And that would be Q prime. So if I were to fold this page in half along the x-axis, P would land on P, Q would land on Q. x-axis. Let's do one with the y-axis. Okay, so I have 3 points. 0, 7 is x. Y is at 7, 0. And z is 0, negative 7. Alright, and I want to reflect this over the y-axis, which is this line. So this will actually, the x and the z are actually going to stay where they are. If your finger touches your reflection in the mirror, if you touch the mirror, your finger touches your reflection. So if you are touching the line of reflection, it's going to stay in the same spot. It's going to be the same thing. So x and x prime will be in the same spot, or z and z prime will be in the same spot. Y, if it went over 7, is going to come this way, 7. And that would be y prime. Okay, and then we have the other common thing that we reflect over is y equals x. Y equals x is this line here. So let's graph our original point, 3, 3. Nope, that was A, B. And C is at 2, 6. So we have this triangle, and if we're going to reflect over this line, the trick to remember when you're reflecting over y equals x, if you have y equals x as the line that you were going to reflect over, you're going to change your coordinates to be y, x. So usually we know that we have the x coordinate and the y coordinate, but we're going to flip them. So A, this 3 goes in the front, this 3 goes in the back, and that would be my A prime coordinate. B, I'm going to put the 4 in the front, the negative 1 will go in the back, and that would be my B prime coordinate. The negative sign stays with the 1, it goes in the back with the 1. All right, and then this one would be 6, 2. 6 in the front, 2 in the back would be C prime. And then I can graph these. So 3, 3. Again, when your finger touches the mirror, your finger and your reflection are in the same spot. 4, negative 1 would be B prime, and 6, 2. Oh, positive 2. Okay. So then if we were to fold the paper along the line of reflection, C would land on C, B, B, and A. All right, and lastly we have rotation. Trying to get it straight. All right. We want to always rotate counterclockwise because this is quadrant 1, 2, 3, and 4. So we want to rotate in the order of the quadrants. So if something is in quadrant 1 and we rotate 90 degrees, it's only going to jump 1 quadrant. We will only rotate 90 degrees, 180, and 270. Those are the only degrees that we will ever rotate. We'll go ahead and plot this. So 2, 4 is A, 7, 6 is B. We have ABC, triangle ABC, and we are going to rotate 90 degrees. To rotate 90, we're going to do 1 turn. We're going to turn our paper to the right 1 turn. 180 would be 2 turns. 270 would be 3 turns. So we're going to turn our paper completely, turn the steering wheel to the right. And we're going to replot our coordinates looking at this as our origin, and we're going to pretend that this is my y-axis going up, which would be positive numbers, down as negative, and this is my x-axis, so this is going left as negative, right would be positive. So from my origin, I need to replot my points. So my coordinates are a distance. That's the path that I need to go from the origin. I would go over 2 up 4. So from my origin, even though my paper is sideways, I'm going to go over 2 up 4. And that will be A prime. B, I'm going to go over 7 up 6. And then C was 5, 8. Okay, so when you turn the paper back straight, we can see that it rotated around the origin. The A is still the closest point, the C is on the left, the C is on the left of my triangle. Letters upside down is fine. All right. If we were to rotate 180, it would be 2 turns, and you would jump 2 quadrants. So if we started in quadrant 1 and rotated 180, we're going to end up in quadrant 3. You do not have to list your quadrants every time. All right, so A is 1, 2. B is 1, 4. C is 5. Okay, I have a rectangle that I need to rotate 180. So turn your paper 2 times. And 2 turns would be upside down. And I'm just going to replot my points. So my A was at 1, 2, which meant I went right 1 up 2. So from my origin, I need to go right 1 up 2 with my paper turned 180 degrees, and that would be my A prime. B was over 1 up 4, so go over 1 up 4. It would be B prime. C was over 5 up 2. And then D would be 5, 4. And you can picture these as rotating around. This rectangle is attached to a string and it is twisting around the origin. So the A was the closest, and the A is still going to be the closest. My D was in the top right corner, so when I spin it around, my D would be in the top right corner if I were looking at it upside down again. All right, we'll do a 270. We have 1, 1. All right, so X, Y, Z, and I need to rotate 270. So this would be 1 turn, 2 turns. I'll spin it one more time. Alright, so 3 turns would look like this. And plot your points from the origin. So 1, 1 means go right 1, up 1. Would be X prime. Y is 4, 3. And Z is 3, 5. Same shape, it just spins. So this one went 1, 2, 3 times and landed 3 quadrants over for 270 degrees.